So for today's lesson, we're going to be solving systems using elimination. Elimination is the third method. And elimination is exactly what it sounds like, to get rid of. So the idea is when you use the elimination method, you want to add the two equations in order that so that you can eliminate one of the variables. You might need to multiply one or both of the equations by a number in order to eliminate. When you eliminate, you need to have opposites or inverses. So if you've got the letter x and one of them is 5x, then a negative 5x will make it eliminate because they're inverses. Or if you have a negative 2y, then a positive 2y is its inverse. You're looking to have variables that have the same number but different signs. So once you get everything set up to eliminate one of the variables, then you are going to go ahead and add those equations together. You're going to solve the resulting equation for the other variable that's left. Whatever answer you get, you're going to substitute that into either original equation to find the value of the missing variable. You should always check your solutions to make sure that you're right. So here's how this first one's going to go. Right now, I do have inverses in this particular equation. The y's are inverses, right? One's positive 1y, one's negative 1y. So if I add these two equations, I get 3x, the y's eliminate, that's the point, equal to 5 plus 1, or 6. Divide both sides by 3, and x is 2. You can choose either the top or the bottom equation to substitute in the value for x and find the value for y. I'm going to choose the top one. You can choose the bottom. It doesn't make a difference. So what happens is 2x plus y is equal to 5. We know that x is 2. So if you do the math, you get 4 plus y equals 5, or y equals 1. So your solution for this first problem is going to be 2, 1. On the second problem, we don't have any inverses of variables. We've got 4x and 3x, which is 7x when you add. You've got negative 2y and negative y, which is negative 3y when you add. I'm going to shoot, though, to make y's inverses of one another. So if I want the y's to be inverses, if I have a negative 2y for one of them, I need a positive 2y for the other, which means I'm going to multiply the entire bottom equation by a negative 2. That gives me negative 6x, a positive 2y, and negative 24. The top equation did not need to be messed with because it has the inverse of what you want. The y's are now inverses. So when you add these two equations, you get negative 2x equals negative 14. The y's eliminated. That was the point. Divide both sides by negative 2, and x is 7. Choose one of those top equations to solve or to substitute in the x value for and solve for y. And I'm going to go ahead and choose the top, no particular reason, just cause. And then what happens here is when I do the substitution, I'm going to get 4x minus 2y equals 10. And then when I actually do the math, I get 28 minus 2y equals 10. Subtract 28 on both sides and get negative 2y is negative 18. Divide both sides by negative 2, and y is positive 9. So the solution to this particular problem is x7, y9. Let's go for the next one. Again, there's no inverses. I can choose to eliminate x's or y's. It doesn't really make a difference. I'm going to go for the x's. Well, a 4 and a negative 3 can both turn into 12. To make the 4x turn into 12x, I'm going to multiply the top by 3, which becomes 12x minus 12y equals negative 24. To get the inverse of the x's, I'm going to multiply the bottom equation by 4. Now I have a negative 12x plus 20y equal to 0. Well, what's great is the x's eliminate. And when I add the equations, I end up with 8y is negative 24, or y is negative 3. Choose an equation, either top or bottom. It doesn't matter. I'm going for the top one. It makes no difference. So what happens here is I get 4x minus 4y equals negative 8. So I'm going to get 4x plus 12 equals negative 8. Subtract 12 on both sides. 4x is negative 20. Divide both sides by 4, and x is 5. So this solution becomes negative 5 comma negative 3. Okay, so here's an example where you had to multiply both. We got one more to go. Let's see what we got here. So nothing eliminates off the bat on this particular one. I'm going to choose to eliminate the y's, which means I've got a positive 2y on the bottom, so I want a negative 2y on the top. If I multiply everything through on the top by negative 2, negative 12x minus 2y equals negative 12. On the bottom, we didn't touch it. When we add the two equations, you get negative 9x equals, in this case, negative 3. Divide both sides by negative 9, and you get a fraction. Not a big deal. Not y, x. So x equals positive 1/3. It's not a big deal if you get a fraction. Now when I choose an equation to solve for, I will solve in y with the first equation. 6x plus y equals 6. 6x, or 6 times 1/3, plus y equals 6. A third of 6 is just 2. Subtract 2 from both sides, and y equals 4. So this solution is 1/3 comma 4. That's it. Okay, good luck on the homework.